Hi everyone, thank you for joining and welcome to this presentation. My name is Fabio Parodi and I am a CPEng here at Cresco Engineers. Today I present a method to design waffle raft foundations on liquefiable soil in accordance with the MBIE Guidance. Many, if not all, structural engineers in New Zealand are familiar with this document since we have been following it for a decade. However, on the other hand, the engineering basis of the guidance remains unclear for most people, since the authors of the document didn't disclose it. And the problem arises when we provide a specific design. In fact, we can't really say whether we are taking all the necessary steps to ensure compliance with the performance criteria set out in the guidance. In this document, I examine a few questions. For example, why, when we provide a specific design, we tend to beef up strength as opposed to stiffness, whereas in the guidance, emphasis is on stiffness? And structural free body diagrams are adequate to evaluate the strength and the stiffness of a foundation on liquefiable soil. If they're not, what method can be used instead? To answer these questions, I'm going to use a case study. However, the results that I will present may be used for a more general application. Okay, let's get down to it. For my case study, I assumed TC2-like performance for liquefaction, a soil with an ultimate bearing capacity of 200 kPa and a modulus of subgrade reaction of 10,000 kilonewton a cubic meter. The MBIE guidance provides information about the ground movement that we might expect on TC2 land. And in particular, it describes the loss of support scenarios, as well as the magnitude of the total land settlements that a TC2 site might experience. For this study, I considered the loss of support of 2 meters at the extreme of the foundation. For these soil movements, the guidance defines the performance criteria that a foundation has to meet. And in particular, it sets limits for its curvature in order to minimize the risk for damage of the superstructure in case of liquefaction-induced soil subsidence. Although in the guidance a few options are presented for foundations on liquefiable soil, in my case study, I considered option 4, which is a waffle raft foundation, 385 mm thick, with ribs at 1200 mm centers. According to the guidance, option 4 is considered to provide a sufficient stiffness to accommodate the expected future ground movements for all but 2-story houses with a heavyweight cladding extending over both stories. Under the combination G plus 0.3Q, we have calculated the maximum point load at the far end of a rib and the uniform load along the rib. Now that all the boundary conditions have been defined, we resolve the problem with a fixed end free body diagram. We immediately find obvious limitations and inconsistencies. Firstly, we are completely ignoring all the geotechnical parameters, and we cannot take into account the deformation of the soil at the support location, nor we can calibrate the results against the magnitude of land settlements. Secondly, the results that we obtain are not calibrated against option 4, because the flexural demand exceeds the capacity of this structure that should comply instead. Some kind of soil structure analysis is perhaps the way to go for overcoming these issues. So we resolve the problem with a simple model where the structure is supported by Winkler springs except where the loss of support occurs. Unfortunately, also this approach comes with weaknesses and inconsistencies. In fact, again, we cannot calibrate the results against the magnitude of land settlements, and both the strength and the stiffness of option 4 this time appear to be insufficient. Introducing the L LIPS method. In developing the LIPS method, we set 4 stringent criteria. The first, the method must adopt equations that are widely used and accepted for soil structure analysis. The second, the method must be consistent and able to describe the loss of support scenarios as presented in the MBIE guidance. The third, the method must allow to incorporate in the analysis the values of the settlements as set out in the MBIE guidance. And finally, the method must be well calibrated against option 4 for the highest permissible loads and for the maximum land settlements. The LIPS method involves a soil structure interaction analysis on an initially distorted soil surface. This method, mimicking the approach used for expansive soils, appears far better suited for the purpose than the simplified methods used before. A parabolic equation has been selected, as equations of this kind have been widely used since the 70s for soil structure interaction analysis of foundations on movement-prone soils. This time, the magnitude of the land settlement is embedded in the equation of the soil profile, and specific results may be obtained for a site with TC2-like performance. Finally, we have a method that is well calibrated against option 4. In fact, this solution is now just right for the highest permissible loads and for the maximum settlements expected for TC2 land. Before I conclude, it is worth it bringing to your attention some further good reasons for not using free body diagrams when you design a foundation on a liquefaction-prone site. Together with the weaknesses that I have already presented, and that is to say the lack of characterization of the geotechnical parameters and inconsistencies of some results, this approach overemphasizes strength at the expense of stiffness, and the permitted deformation set out in the MBIE guidance might be exceeded. Furthermore, this approach does not provide information about the actions beyond the point where the loss of support occurs, and therefore also the structural demand might be underestimated. The results that I presented today have been obtained with the Waffle Suite software, which is a free cloud-based FEM software that uses the LIPS method and that complies with the New Zealand standards. Waffle Suite is a great tool as it performs complex analysis of waffle rafts involving different loss of support scenarios and multiple load conditions. As my team and I produce hundreds of foundation designs every year, we felt the need and the urgency to delve into this topic. I have been fortunate enough to work with Angela Liu from Brands, who took me in the depth of the MBIE guidance, and with Dean Cook from Firth, who has been a very helpful devil's advocate. So I'd like to thank both for their incredible support to this research. You will find our contact details as well as a link to the Waffle Suite at the end of this presentation for your convenience. Thank you for watching.